Hello, in this short movie I want to present my LabVIEW application called LabVIEW Guitarist. The purpose I wanted to reach was to implement some bass guitar effects and easy interface for handling actions like acquisition of sound, reading and saving files, and of course sound signals processing. All functions used in my application based on my own algorithms and experience in guitar playing. So let's run the application. After it starts, the program displays an user interface, which we can see on the screen. The interface is divided into three main sections, responsible for particular functions. The upper left zone is a status section and shows actions performed by program. In this section we also have a stop button, which ends the program. On the right, we see a tuner section. The largest is the processing panel. There are four effects implemented in the application: distortion, tremolo, delay, and noise gate. Here we also have buttons for some actions we can perform. For example, recording sound to file, opening a file, listening and mixing down processed sound. The guitar tuner is very useful for every guitarist, so I implemented it in my analysis part of the thesis. The program collects sound samples from microphone or line input, independently recognizing the source. After starting a tuner thread, it recognizes played string and its current frequency, and then shows this data on text indicators. At the same time, it turns on a control light dependent on the frequency. The green light means that the string is finally tuned and we can start tuning another string. The tuner will recognize the change of the string. If we have our guitar tuned, we can start using the processing panel. First effect I want to present is located on the bottom of screen and is called noise gate. It cuts the output signal after reaching specified conditions. The level knob represents the level of magnitude under which the gate will cut the signal. dt represents the time after gate will affect. Now I will set some parameters and demonstrate working of the gate. I made some noise and recorded my voice by using the rec function, so now I will open this file. Now I can listen the sound I've recorded. Noise gate test. Noise gate test. Okay, so now we should use the noise gate. I will set it on and set some parameters for this presentation. We have already opened the WAV file, so we don't have to do this again. Now the parameters set, I can listen again and listen what have changed. Noise gate test. Noise gate test. Noise gate works. Okay, let's try some effects now. We will start from the delay, and we will use for this music of a great band in Green Street project. I will set some parameters like feedback, frequency and gain. Then I will open a sound sample, and then I will switch off the noise gate and let's hear the effect.
Znów kolejny obraz budzi mnie. Pełnia kolorów, jest wszystko czego
sounds pretty cool. Now I think we should make some noise. I will open a sound sample and set up some distortion parameters. We will first listen the pure sample and then I will switch on the distortion. Okay, let's try the tremolo now. We can set such parameters as frequency and depth of vibrating. I will open the sample and as before we will first listen the pure sample. Now let's hear it with a nice tremolo. I think that we should finally use the function called mixdown. For this, we will use all three effects. I will also show you that my program is very intuitive and signalizes problems. If we, for example, don't choose file, we will see a dialog box. Now with no file opened, if we will try to listen, we will see another one. But what we want is testing some sound. I will open the last test sample. And now I will set some parameters of delay. Okay, let's listen the pure sound. It sounds great, but I think it could be much better with distortion, tremolo and delay. I will now mix down the final sample. I will set off the three effects and click mix down. I will choose the output file and confirm. Then, as we could see on the status bar, the mix down is complete, so we can open it with the default player. The application was built on 4 threads connected with each other with queries and notifiers. There is an acquisition, tuner, processing and user interface thread. User interface collects data from user and basing on them sends commands and informations to front panel and other functions. Acquisition thread receives data from input and sends it to current working thread, record or tuner or any other. Tuner makes calculations basing on data from acquisition and sends status to user interface. Processing thread performs such actions as listen, mix down, open file, close file and record. All threads works parallel. The program works stable and doesn't use much system resources. We end program with one button which ends all 4 threads at the same time. So this is the end of this short movie. Thanks for watching and have a nice day.